All right, today we're going to talk about going reactive with Play and Akka. I have the help of Nilanjan. Nilanjan, raise your hand. He's with Typesafe Professional Services. Kip Sigmund, also with Typesafe Professional Services. And we have Havoc Pennington, who is the tech lead for Activator, who's built most of it. So if we have any technical issues, we're going to ask Havoc. So this is kind of a usability test as well, right? So we'll see if it actually works. So the idea today is this is really just kind of a hands-on workshop. We normally do this in 2 to 3 hours, so this is kind of a time crunch, 45 minutes. So we're going to try to jam a lot in here. But these guys are walking around helping out, so let us know, raise your hand if you need help, you have any issues as you go through this. Right, so Typesafe, if you haven't heard, we're all about going reactive. That's our main push is reactive applications. We've published the Reactive Manifesto. The idea with the Reactive Manifesto is it's talking about, reacting to scalability is reacting to load. We want to be able to scale in a reliable fashion. We want to resilience is all about reacting to failure. We want to make failure first-class events in our system. We want to be able to react to these events, right? And then we want this whole system to be event-driven. We want to be able to react to events as they come in. So instead of a traditional, very pull-based model, we want to make an event-based push model. And really the end goal is to make a responsive application. We want to be able to react to the end user, make a very responsive application that responds in real time. It's very fresh and live. It's very much, this is very much the way mobile applications are going today. The Instagrams, the Facebooks, this very responsive, up-to-date, real-time feed of your information. And the way we're going to do this today, this is basically we want to build a reactive application today. And we're going to use a couple of different pieces. The primary piece we're going to use is Play. If you've never used Play, Play is a high-velocity web framework. The idea with Play is it was built from the ground up to be very reactive. It's completely asynchronous. Everything it does is asynchronous. It's stateless. So none of this. So the reason is being stateless, you can completely scale horizontally. There's no state stored on the server. It has a very unique workflow. It's just a hit refresh workflow. It's not the model of having to build your application, deploy it to your app server, redeploy your app server. We try to make the whole development process a lot easier. And then all the endpoints in Play are RESTful by default. The idea is to make this your application, make it very easy to build RESTful applications. And then type safety is obviously a key part of the Play web framework. So everything that we talk about is type safety, from the views to the templates, the view templates to the routes to the controllers. Everything is checked at compile time. And so it's all type safety. So the idea with Play is it's a very different model for how it deals with the traditional request response of a web framework, right? So your traditional web framework comes in, it has a blocking call to the server. The server holds onto that thread, it blocks that thread, and it makes the calls out to backend services, and those are blocking calls as well. So you have this very synchronous blocking chain of this in a traditional web server that's request response blocking all the way through. What we want to do is we want to break up this blocking. We want to make this completely non-blocking. So when the client makes a request in the server, we want that request to be non-blocking. As the server's doing the processing, we want to be able to release that thread, allow that thread to be handling other requests as they come in. And then we want the server processing in the back end out to external services to be non-blocking as well. So we want to make everything asynchronous and reactive. The way we're going to do this is we're going to talk about a couple of different kinds of reactive. And we're going to actually build these today. The first is just we want to show a basic reactive request. The second is two-way reactive. And if we get time, hopefully we'll be able to get all the way through to reactive push. So by now, hopefully you've been able to get Activator installed and running. Anyone need Activator USB sticks? Anyone need help installing Activator? No, sorry. I didn't think of installing the US JDK, sorry. All right, so once you have Activator installed, you should be able to go to filter templates and search for tweet map. So you should be able to see this tweet map workshop template. You can also, it's also on the USB stick, you can open it by using an open existing app, or you can just find it under the list of tutorials. Go ahead and open that up. I should introduce Activator. What Activator is, it's a lot of things, but one of the things it is it's a kind of a launching point into the Typesafe platform, and it has a lot of templates and tutorials to help you get started with the Typesafe technologies. And the idea is these templates walk you through the steps of building different Typesafe technologies and helping you understand these Typesafe technologies. So it's a lot of things around the Play web framework, around Akka, Scala, and the Activator templates we were getting a lot of contribution from the community. We really welcome community contributions and having people help write these templates to help other people get started. With Activator, you notice on the, let's see here on this side, can't quite see the side of the screen. All right, so on the side we have the main tabs for Activator. All right, the tutorial tab is going to bring up the main tutorial. And under development, we have the code, compile, test, run. The idea with the Play, as I mentioned with Play, it's this just hit refresh workflow. So once we've compiled it and we hit run, it's going to continue running, and then any changes you make to your files as you save them, it's going to recompile them and basically update the server so that you get the latest copy. So you don't have to go back into run and stop and start the server every time. You'll get the latest changes every time you hit save. Hit the wrong tab. Right, so if you've got the tweet map open, you should be able to go into run. Let's see if I close this. Right, you should see the server started. It should be running for you. And it's running on port 9000. So I should be able to go to localhost 9000. It's going to take a minute to compile. And it didn't go the first time. Oh, there it goes. All right, so that's kind of the starting point we're going to start with. This is a basic Play framework, and we're going to take this and make this into a completely reactive application. So let's go into tutorial. If you go into tutorial, the first thing we want to do is a reactive request. So the way Play web framework works is it's like a lot of web frameworks that you have a routes file. The routes file basically is how the requests get routed when they come into the Play framework. So what we want to do is we want to start by adding a new route. So you should be able to click on the conf routes. Let me minimize this over here. Right, so what we've done is we've added a new route. What we're saying is when we get a search request, a search URL, we want to go to the controller search tweets.search and execute that query. So this query is going to be a URL query that's going to come in. And so what we want to do with that query is we want to be able to search Twitter with that. So now if we go to the next step in our tutorial, right, we wanted to update the tweets.scala. Oh, cancel, I forgot to save. So I click save. All right, so I go to tweets.scala, and here's the code that I already provided. So let's copy these imports into the start of the file, drop those in there. And then we're going to drop in a reactive request, and I'll talk a little bit about that code. All right, so starting down, let me see here. You probably can't see the bottom of the screen. No, wrong way. All right, so the fetch tweets method, what this is going to do is this is going to go out and it's going to fetch tweets. I'm not fetching directly from Twitter. We're using a Twitter proxy to avoid like API keys, things like that. And what this is it does the ws.url. That's a web service call. That's the Play web service call. And what the web service call does is it returns a future. So what a future is in Play, or if you're familiar with Scala futures, right, Play wraps a Scala future. What a future is it's an asynchronous calculation that's going to happen in the background. So what we're basically saying is we want to make this web service call in the background on a separate thread pool, And we want the response of that web service call returned to us in a future response. So we don't want to block on that web service call and wait for it to come back. We want to fire off that web service call and basically get a handle of the future response, right, and then add a callback handle onto that future. So when that future gets completed, at that point we actually handle the response. And that way we're not blocking. So up here you'll see that we get the tweets future back. The first thing we're doing is we're filtering it. So we're saying when we get that future back, that future response back, we want to filter it, and if it's an status okay, if the response is good, we want to go ahead and process it. And what we're going to do with that future is the first thing we're going to do is we're going to do a map. So this is if you're familiar with Scala collections, it's very similar to a Scala collection mapping. We're going to take that response that comes back and we're mapping it to a response.json. All right, and then we're going to recover. If there was an error, we want to add a recovery method to it, a recovery callback. The recovery is basically just going to put an error string in the JSON for us. And that way, what you're going to see is this proxy actually fails about every 5 to 10 calls. So you will see this error happening. We randomly fail on about every 5 to 10 calls on our proxy just to simulate errors. All right, so now we've made the web service call. We're returning the future of a response. So now what we want to do is we want to add a controller. So in the Play web framework, right, we have a request that goes into a URL routes file. That URL routes file specifies the controller. So in our routes file, we specify the controller that handled the search was the search controller. It takes the query string parameter. And what it does is it's going to return an action.async. You can think of that as basically returning a future response. So we don't want to immediately return a response back to this client. We don't want to block while we're going out and fetching the tweets. We don't want to do any kind of blocking. We want to make this fully asynchronous. And so what we're going to do is we're going to return back to Play a future of a response and not an immediate response. And so when we do this fetch tweets, the fetch tweets is going to return a future, and then we're going to map that future to a response. So we're going to get back the tweets, and we're going to map that back to an HTTP response that gets returned back up to the client. And here we're mapping it to an OK tweets. So the next part of our tutorial, so that's the basics of a reactive request. So this is very different than a servlet model where we're blocking. Instead, we're returning a future response that only gets fulfilled when the response comes back. So the next part is we want to update the client side. With Play, what Play does is you can actually use what's called web jars, and we're specifying our dependencies for our client as jar files. So you'll see here, basically as library dependencies, we have several web jars already defined, like Bootstrap, jQuery. These are all the dependencies for our client side. So those have already been added. If you notice, the Play has its own templating language called Twirl. We've already added Angular to the Twirl templates, right? And so the source, right? So we've got the source for AngularJS already defined, and we've already defined the Angular application. So all we need to do is update our index.js. So we need to update the index.js and copy this. All right, then we want to update the index.scala.html. So we want to modify this so we actually display the tweets. Right now it's just displaying a message. So what we want to do is basically delete everything that's in that file and save it right to display the tweets. It's going to use Angular to display the tweets. And all it's saying is repeat on the tweets value to display them all on the list. So we pull this up. Hopefully we see this working. So you notice I didn't have to redeploy Play. All I had to do is save, and it's going to automatically recompile things in the background for me. All right, so now let's make a search, Scala days. There we go. All right, so what it's done is it's made this asynchronous request out to the Twitter search. It's returned the response back to us in JSON, and we're displaying this as a basic trait in a basic HTML list. Who has this much working? Has anyone been able to get this much to work so far? Is anyone following along? Still resolving dependencies. Is everyone just waiting for the application to resolve dependencies still? Man. So is everyone waiting for the tweet map to still just like the application just to open? All right. Well, hopefully you guys can do this afterwards. We'll be around afterwards, I guess, and so such as it is. All right, well, let us know how it goes, I guess. All right. So that's a high-level overview of Play. So Play has this, right? So you have these routes files. You have the route file, you have the controllers, and you have the views. And you put these together, and you can make these reactive requests. Now, the next piece we want to tie into this is the Akka framework. So I'm throwing a lot of technologies at you. We typically take at least a couple hours to explain these things. So we're throwing these at you really fast. So if you don't understand any parts of this, please feel free to talk to us afterwards. So what Akka is basically it's actor-based concurrency. And what you can think of as an actor is it's like a normal Scala object, or or even a Java object. The difference is you don't call the methods on that actor directly. Instead, it's message-based, right? So you're never interacting with your actor directly. Instead, you're interacting with it via messages. So you send messages to your actor, and it's going to respond to those messages. So it's very much of an event-driven model. What this gives you is a very sane concurrency model. The idea is that Akka is going to manage the concurrency of your actor for you. Because you're not interacting with it directly, you're just sending it messages. Akka can determine when it gets run and when it's processing its messages. And this allows Akka to manage the concurrency of your actors for you. And what's different about actors is they are not a request-based lifecycle. So they're very different than a traditional web framework that's a request and response. Instead, they're fully event-driven on these messages. And the other unique thing with Akka actors is because they're fully event-driven and Akka is managing them for you, is Akka can manage the failure of these actors for you. Right? So if your actor dies, Akka can restart your actor. You can specify to Akka just stop my actor if it fails, or do all sorts of different failure handling on my actor. So the idea with Akka is, right, because it's actor-based and we're building everything on actors, what we get is a very highly concurrent framework for building our applications. So everything becomes very asynchronous and it's fully distributable. And what that means is, so the way we build our actors is we build them in a hierarchy. So you build it like a file, you can think of it like a file hierarchy. You have a parent actor with child actors. Right, and so the parent can create as many children as it needs, and those child can create their own child actors. And the idea is having this parent actor with your child actors, the parent can manage the child actors, and it can supervise those actors and deal with their failures. Well, the other advantage of this is it becomes a very distributable model, because we can take these actors and we can spread them out across a cluster of nodes. We talk about scaling up and scaling out. So scaling up means leveraging all of the cores on a CPU. Right, because everything is very asynchronous and loosely coupled. It's very easy for Akka to manage the concurrency and scale up your Akka actors. And it also makes it very easy for them to scale out. All right, so that means leveraging multiple servers either in your data center or in the cloud. So the next thing we want to do with the Activator is we want to build a WebSocket with Akka actors. So with Play Web Framework 2.3, what they did is they basically made it really easy to create and manage your WebSockets with actors. They added a method, basically you create your WebSocket and you hand it an actor. What WebSockets are, if you're not familiar with the WebSocket, it's basically a two-way communication pipe from the client to the server. It's a very asynchronous model because what the client does is it just sends a message down the pipe, the server processes it, and when it's done processing, it'll send a message back up the pipe. So WebSockets work really well with this reactive event-driven model because it allows us, there's not this, the client isn't waiting for the response when it sends a message down the pipe. So let's take this code. So what I'm going to do is I'm first going to build a really basic Akka actor, kind of explain to you how the Akka actors work. And then we're going to wire that into our Play web framework to handle a WebSocket. So let's take this actor. All right, so the instructions say create a new user actor, Scala file in the app actors. So we come under here, new file, user actor.scala. Save. So let's talk through this actor just a little bit. Class user actor extends actor, right? It's a normal Scala class. The only difference is that we're extending actor. We have a maybe query that's an option type. The idea is that we only want to start querying Twitter when we get a query available from the client. So as it starts out as a none, it'll become a sum once it's available, so we know when to actually start querying Twitter. And then we have a scheduler. So the idea with this is what we're trying to do is simulate an event-based system. So we're simulating events coming from, right, if we're like having a real-time, Twitter stream, having the Twitter feed coming into us in real time and we're reacting to it as an event-based. So we're going to try to simulate this by using the scheduler. Right, so what we're doing is we're scheduling that every 5 seconds we're going to send a message to ourselves. And the message we're going to send to ourselves is fetch tweets. So every 5 seconds we want to go out to Twitter and see if there's new tweets, and if they are, we want to push them back up to the client. So as I said, the actors, you never interact with them directly, so there's no methods that get called from a client. Instead, there's a receive block that handles messages as they come in. And this particular actor handles 2 types of messages. The first one is fetch tweets. That's our way of simulating events. So whenever we get that scheduler fetch tweets message, we're going to go out to Twitter and fetch new tweets. You'll notice that it's on the maybe query, right? So we're only going to do those fetch tweets if there's actually tweets available. And the second thing we're doing is a JS value. The message JS value is a message that's going to come from the client. So we might get a JSON message from the client. If that message comes in, right, and we get the query out of it, we're going to set it to a string, and we're going to use that for our Twitter search. So, and then one other thing I want to point out, and this is new with Play 2.3, is we have this out actor ref. And how this works is with Play 2.3, it automatically wires in an out actor for us. And what that out actor is whenever we send a message to the out actor, Play is going to take that out actor, the message that was sent to the out actor, and it's going to send it on up to the client. So what Play is doing is it's managing that communication to the client for us through this out actor ref. So you notice here when we get a tweet update, all we're doing is we're saying a out bang tweet update. I should clarify, bang is how we send messages in Akka. So that's basically a tell. We're saying we have the out actor, and we're saying send the out actor a message. The message we're sending is tweet update. So in Akka, you have the bang is kind of the way you do this. Right, so that's going to fire off a message to that actor. And that's going to be an asynchronous message. So that's not processed immediately. What that does is that's going to put that message in the actor toolbox and allow the actor to process it on its next round of updates when it pulls the next message off of its mailbox. And so that out is going to be pushed up to the client. So now the next part of the tutorial. So now we've built this basic actor. What we want to do is we want to wire the actor into the Play controller. So let's see here. Where's the code for the Play controller? So that's the next step. We want to wire up the WebSockets. So the first thing we do is we just add a route for the WebSocket. So you notice the routes, it's just a normal routes file, a route entry in our routes file. We're just going to say WS for WebSocket. So the client just tries to make a connection on WS, right? And then all we need to do to build the WebSocket connection, oh, I always forget to save. I think I didn't save my changes. Let's see here. All right. So now we need to add a couple of imports for our actors. Save those. And let's add the line to create a WebSocket. And we'll talk about that. Well, you notice the code for creating a WebSocket in Play is very easy, because all we're doing is we're saying WebSocket except with actor. And what we're doing is we're handing the actor to the Play method, right, to the Play function, and it's going to take that actor and it's going to create it wiring in the outs for us. The one other thing I forgot to talk about is the user actor.props. So what props is, here, I'll pull this up really quickly. User actor has this props, which is basically the properties used to create our actor. It basically, we hand this props function, or this props method, to the client, to the controller, and it basically tells the controller how to create the props for us. Right, so if we go back in our apps controllers, right, so when we say except with actor, we're saying user actor.props. We're not saying new actor. We want to use the properties method, and this is going to allow Play to create the actor and wire in the out for us. All right, so now that we've kind of wired up our basic WebSocket, we need to update our index.js. Before we were doing a web service call to our RESTful endpoint of Play. Now what we want to do is we want to make a WebSocket call. So let's go into index.js, and we're going to copy this code. This is basically going to update. What we want to do is we want to change in here where we used to have a RESTful call. We want to change this to connect to a WebSocket. Right, so in our client, all we're saying is connect to that endpoint, right, the WS endpoint. And what the WebSocket is going to do is, right, when we enter a query, it's going to send a message down the WebSocket. It's going to basically take our query and code it as JSON, send it down the pipe to the server. The server, when it gets a query, it's going to send a message back up. And so we're adding a on-message handler that's just going to update our tweets. So now we've got this two-way asynchronous communication between the client and the server. So let's go ahead and update Play. So anyone have it up yet? Anyone get the dependencies resolved yet, or is it still resolving dependencies for everyone? Still resolving dependencies? It just finished. We have one person. Good. Pounds. All right, so if we do a search, we should be able to see something come up. So the way we can see what's happening is we can use the network inspector to look at what's happening. Let's refresh this and see what's going on here. There we go. Cool. So if we go under our network inspector, we can actually look at the web service calls, and we can look at the frames as they come back. Right. So there's our error handling. Right. It's failed. Right. So we get how did it handle the recovery. So you'll see the tweets are being updated in real time. This is the event-driven, right? So what's happening is we've made that query one time, and then the server's pushing up new tweets as they come in. So let's do something like Scala days. And there's a bug in the Chrome inspector so that it only updates your frames when you click in and out of it, right? So but here we can see the text as it's being pulled in, so it's setting up the queries. So, all right, any questions to date on any? Do you want me to clarify any points of how these things? Yes.
Do we have an actor for each connection we have to this application?
Yes.
And each of these actors is querying the Twitter service?
Yes. So the question is there a new actor for every WebSocket connection? And the answer to that is yes. So what's happening is every connection that comes in, now I'll go back to that code. App, controllers, tweets. So every new client that comes in, we're going to create a WebSocket. So that WebSocket.accept with actors is creating a new WebSocket for each client, and that WebSocket is creating a new actor to handle that client, basically, and that actor is going to be running asynchronously in the background, managing the connection, right, and sending up the new tweets. Any other questions? You guys understand everything perfectly up to date? Yes? All right. All right, well now what we want to do is we want to display this on a map. All right, so right now we're doing this push update and we're displaying new we're displaying new tweets as they come up. We want to update this to try to display these on a map. So what we want to do is a lot of tweets don't actually have geocoding information, the latitude and longitude, so we're going to fake it. So I'm going to add this to our imports. We'll just stick it down here. My code formatting is completely off. That's okay. And then we want to update the fetch tweets to actually go grab that JSON, the GeoJSON encoding. So if I grab that, where's our fetch tweets? My code's looking pretty ugly at this point because the indenting's all messed up, but that's okay. Right, so now you notice that when we fetch the tweets, what we've done is we've changed it to grab the tweet latitude and longitude. And what that does is that's going to basically put the coordinates in our JSON to display in the client. So now that our client has this JSON available, we want to update the client to be able to display this in a map. So the first thing we want to do is we need to add leaflets, which has already been done for us. You'll notice in the build SBT, we already have dependencies on leaflet. In the main Scala.html file, this is our view template. Right, we've already added the dependency on leaflet, and we're using the Angular leaflet directive to make it easier to use leaflet. So then in our index.scala page where we're displaying the tweets currently, what we're going to do is we're going to change it to display a map. Right, so now and all we have to do to display the map is we just say, right, leaflet, and then we're just wiring that to the markers, which is going to be created in the Angular. So now we need to update the index.js to add the ability to wire in leaflet. So we add that. That adds the leaflet directive. Whoops. I think I copied something wrong here. Hold on, I broke something. I overwrote my file, so I've got to grab the new one to be sure I get everything correctly. I deleted that app factory. Let's try this again. So we just want to update this. All right. And we need to update. So this is where we're going to grab the JSON, and we're going to update the latitude and the longitude. Right, so this is going to allow the client to update the latitude and longitude. I just realized I changed back from using to west for lens points, so we've got to change this back. I really messed up my JSON. There we go. All right, so hopefully if that all works. All right. So now we're displaying a map, and now when we do the search, if it all works well, we should be able to see the endpoints being, yep, there we go. Cool. So there, now what's happening is we're seeing the Twitter search is showing up on a map. Yes, you like that? People are on a cruise ship tweeting about Scala days. We're so popular. We're getting tweets down the Antarctic. We're all over the place. So this is the problem with our randomized latitude and longitude, that they're not very accurate. Yeah. Right, so now we've wired up the JavaScript. So if we go back and let's just look at this controllers again. We can talk a little about this right? So what we're doing is we actually go and we try to pull the latitude and longitude out of the JSON, and we actually use the Google API to try to to encode it. But if that fails, and we're not able to do it, we actually do a random latitude longitude, right? So we're just trying to approximate the latitude and the longitude, and that's why it's coming up as not completely accurate. So, has anyone gotten this to work? Is it still resolving dependencies for everyone? You got it to work? 2 people. 3. Oh, look, we're getting a couple people. It's working. Cool. Yeah. All right. Any questions? So who here has used the Play Web Framework before? All right. Have you guys, who's using it with Akka and actors? Have you guys used it before? Cool. That's great. So hopefully this helps you understand how to use the Play Web Framework with Akka actors. All right, I think the key is the wiring in the WebSocket with actor except with actors. So, any other questions, comments? What about testing? Yes, testing. Yes, I forgot that part of my. Yes, so actually, what Play does is it has a whole testing framework that you can use for testing. I can take a minute and explain that. So if we go back under test. Well, I'm not going to take the time. Let's see here, what's the best way to explain it? Right, so what the testing does, right, you'll notice that what we can do is we can basically create a fake application. Right, so we're saying with application, and then from that application, we can do a request into index. Right, and so here we're saying the index must contain the line Coco. Right, and so we're verifying that our index page gets rendered with the text that we expect. Right, so here we're doing a with application, and we're getting a get, we're on the root request, we're doing a fake request. Right, and so when we do this request into the root, we're saying the status must be, right, the status of home must equal to OK. So we're faking a request to the index, and we're checking the status response, and then we're going to check the content. Right, and then the last test is, right, we want to search for tweets within applications. So we're going to simulate doing a search, and right, we're going to just verify that the status of the search must equal to OK. Right, so we're simulating doing a search out to Twitter, and we're verifying the response that comes back. So Play has all this mechanism for doing these types of tests for our main controller, for our routes file. This example is using specs2. With Play 2.3, we've become very agnostic to type of testing that we can use. So you can do either Scala test or specs2. So that's testing the controller. And the other thing we want to do is we want to be able to test the actor. So testing actors is very different. Because actors are very asynchronous message driven, we just can't call an actor methods, right, and write tests around it like we normally would. What we have to do instead is simulate the actor system and simulate testing it. All right, so if we look through here, we're going to do things like we're going to make a test actor ref. What the test actor ref is going to do is it basically is going to look for messages. So we can wire in this test actor ref, and we can look for the out messages to come back. And so what it's going to do is it's going to basically monitor the output stream and be sure that the actor is sending messages back up to that are expected to go to the client. It's basically probing those actors to verify the responses are correct. And the other thing we can do is we can get the user actor ref.underlying actor. So we can actually look at so like when we send it a JSON query, we want to verify that the maybe query was set underneath the covers. So we can send it a message, and then we can get the underlying actor and kind of do an inspection on it that way. So those are kind of the two ways of testing play in Akka. Any other questions? Well, one other thing I didn't talk about, I think is another key piece of Akka actors, which we really can't see too well in this application. We go to the code. Let's see, pull up actors. So the thing with an actor is we never create actors directly. One of the key differences with an actor is if we were to create it manually, so say for example, I don't know, here in index, if we wanted to create an actor manually, we would do like something like a, I can't code without my ID, but basically you do a akka.actor of, and you pass in the property. What that's just saying is this is going to tell the Akka actor system, create me an actor of this type. And what it's going to return is it's not going to return an actual pointer to the actor. Instead, it's going to return what's the, like a actor ref, user actor ref. So it's basically a reference or a pointer to my actor. It's not the actual instance of my actor. So when I do this actor of, what Akka's doing is it's actually going off in the background and asynchronously creating the actor for me, and it's returning a reference to that actor. And that's a pointer to the actor. And what's really important is that's location transparent, which means that I don't care anymore where my actor's living or running. So the actor can be running on my local machine or in a cluster. And because of that, right, I can send messages either to my local actor or to an actor running on a separate node in the cluster. I don't care where that actor is living or existing. And that allows a lot of interesting distribution with my actors. Right, so we talk a lot about in the Reactive Manifesto about being scalable. So here with this actor, I want to scale these actors out. I want to make them independent components that can scale easily and independently. Well, by using these actor refs, I can kind of scale out my architecture in a very horizontal, loose fashion to make it very easy to scale. The other interesting thing with the actor ref is that it allows me to deal with failure and error handling. So if my actor dies and gets restarted, my actor ref is still going to be valid. So it could be, right, so a client could have a pointer to that actor underneath the covers, right, and the client could have a pointer to my actor, and underneath that covers, if the actor dies and is restarted, the client doesn't care. The next time it fires off a message, that actor ref is still going to be valid, and that actor is going to be able to receive the message and process it. So that allows us to be very resilient to dealing with errors. So this actor ref gives us a lot of flexibility in how we deal with our actors. Any other questions? All right, if everyone can, oh, yes.
Regarding one of your first steps, you've made an async action for the first request. What's the benefit there? Because the connection is left open until the result is there, so I don't save any resources or...
Oh, if it's just like a basic synchronous request? Yeah, so underneath the covers, right, you can either do, let's see, where am I at? Yeah, so we can do basically either just a basic action or an action.async, but underneath the covers, Play makes all of those asynchronous. They're all, basically every request is asynchronous by default. The only thing that action.async does for us, if I can pull this up, let me scroll down a little bit. Right, so this one returns the action, this one returns the action async. Underneath the covers, these are actually end up being exactly the same. They're both asynchronous. The only thing the action.async does is it allows us to return a future of a response instead of the actual response. But in the Play is still going to do this asynchronously, right, and free up the thread, allow the thread to handle another request as it's coming in. So they're both asynchronous. Does that answer your question? Okay. Okay. Yeah, if you can hand the USB sticks back to either Kip or Havoc or me, I'd like to pick those back. So yeah, and let us know once all your dependencies get resolved. If you try to build it either tonight or tomorrow, let us know if you need any help or we can answer any more questions. So thank you everyone for coming. Appreciate it.